Hello, everyone. I hope everyone is ready to learn some things on how to improve performance with the Mendix applications. So in the agenda today, we're going to talk about users and what kind of problems they usually see. Then we'll go into the background information and how Mendix works. Then we'll do a little bit of a problem analysis on how to identify any problems with performance. And then we'll go over into best practices for the server and browser performance. Before we go any further, I just want to make a little bit of an introductory remark. Performance is a very context-sensitive issue, so it's always a good idea and important to test your specific case and always test with realistic data. No matter what, if you're not testing your application acceptance with production data, when you go into production, you're bound to find any items that you might have missed during testing. So always test. And again, I also want to give a little bit of a disclaimer that these are guidelines and not laws. So these are best practices and things that you can do to improve your app performance today. So why are we doing this webinar? Well, the important reason for it is because performance in today's fast society is really, really important. Users are expected to see things happen in microseconds instead of seconds. And they get very, very frustrated when something doesn't happen fast. So usually from the end user's experience, you have actions that might take too long where nothing happens, or you have a long running progress bar where they're getting bored and don't fully understand what is going on. The other issue that the users might experience is the page is opening up too slowly, and usually that results from complex pages or when you have large context data. So it's really important to keep the users engaged into the application and make them feel that the performance of the application is up to their standards. So here's a little bit of a background on how Mendix works. So this image provides a high-level overview of all the components. You have the Mendix client, which is usually a browser or Firefox or Mozilla and so on. And the Mendix client interacts with the Mendix business server. And the Mendix business server is where you're executing actions in the model, and it's a nice separation between the logic and the data layer. So the Mendix business server is what sends queries, for example, to the database. So delving a bit deeper into the business server, it provides just standard. And those actions are used by the client and the Microflow. And the Mendix business server, again, deals with the database. The web client is where you're rendering the pages with widgets using HTML and JavaScript. And you can access objects through all the available actions. So what happens if you're trying to execute an action? The first thing is the client interacts with the Mendix business server, where it requests to execute a Microflow. Then the Mendix business server sends that request to the SQL queries and adds or applies the security to retrieve the data set from the database. Once the database retrieves the data set to the Mendix business server interacts with the client to display that data. So with Mendix, instead of having tables, you have a visual representation of your objects. So what you have is entities. So in this example, you have a customer and an order, and you have associations between those entities. So one customer can have multiple orders, and one order can be referenced by multiple customers. The traditional method for this is a result of a SQL database table, or any kind of database table. One for the customer, one for the order, and then the association is represented in a joint table between the two foreign keys of the customer and the order. So what happens when an object is being retrieved? For example, we're trying to retrieve the customer by the name of Tom, and the schema, or what we want to present or show to the user in the page, is just the name and the city. So this XPath constraint is converted into an OQL query, and the OQL query is converted into a traditional SQL query. So now that we've covered the basics of how Mendix works, we're going to go further and analyze what potential problems you could have in your application. So this, for those of you who are familiar with Mendix, is a microflow, which shows the logic on how you can troubleshoot any kind of performance issues. So we're going to delve deeper for today into the microflow items and what you can do to improve your microflow and your domain model in relation to your behavior in the application. So the first thing that you should do whenever you have a performance issue is always be able to reproduce the issue that the users are having. That is the first key. So step 0 is to reproduce the issue that the users are seeing. Because if you cannot reproduce the issue, then it's much harder, if not impossible, to troubleshoot. The next thing you want to ask yourself is the issue that you're seeing a user interface issue, or is it a microflow issue? What I mean by user interface is, for example, is the page taking too long to upload? Is it taking too long to open, or are data not being properly displayed? While a microflow issue would be something where you have an action or an import that's taking too long, or you have a button and the users are not seeing any actions. And when you have those kinds of issues, that's where you can do a lot of things to optimize the microflows. So to optimize the microflows, you might want to review your microflow and add timing logs to your microflow to see which actions are taking the longest, and also to identify what is slow and what isn't. So once you identify the slowest action, you might want to see if you found anything. If you did find something, then you might want to optimize that. So possible causes of issues could be a slow retrieve action. So in that instance, you might want to add indexes to your database, improve XPath constraints. You might have slow sub-microflows. Then you might want to optimize loops or commits, or it might be a web service call. In that instance, you might want to check the mapping, or if it's an in-networking issue. If you don't find anything, then you might want to think about the microflow as a whole and try to optimize it that way. One of the most common issues that I see is that users or developers do many commits within batches. So it's important to remove unnecessary commits. Make sure that you're retrieving the data once, since there are multiple times within the same microflow. So what kind of tools can you actually use to identify these issues? Well, you can always use microflow timestamps. You can use the microflow debugger, as well as the server log nodes. The most common one of the server log nodes are the connection bus and web services. So now I'll show you with an example where you can find all these items. So this is a microflow, and it's a scheduled event which sets the course statuses. So for those of you that are familiar with our training course, this is an application that manages trainees and trainers and scheduled courses and subscriptions to the scheduled courses. So this is a proper example of how to add log actions into your microflow. The first thing that you want to do is you want to create a date time variable. And that date time variable, you can set it to be the current date time. And in order to avoid any confusion, we'll call this the start time. Once we schedule the start time, we create a log message. And in that log message, we can select the log level. So we could have it as information, we could have it as debugging or tracing. And I'll go into a minute of what that log level means. Then you want to set a log name. So in this instance, the log name is set course statuses. And then you want to configure a template. So for example, started scheduled event set courses at the parameter number 1 is basically the start time and the format of that start time. By, and then you have the current username. So you know who triggered this microflow when. You want to keep the template or what you're saying in your log message as clear as possible so that it's easier to troubleshoot and for users to know where the issue is happening and by who. So keep in mind to be as clear as possible when you're creating your logs. So in this instance, we're creating 2 log events, one before we have the microflow running, and then the second thing is after the microflow has happened. So you want to write a message such as ended scheduled event at this time by this user, and then the total duration, usually it's the difference between the current date time and the start time. So you want it to be milliseconds between, because actions usually take milliseconds to complete. Don't do seconds or hours. If you're doing hours, then there's something wrong with what you're doing. So make sure that you use this microflow expression to be milliseconds between the current date time and the start time. So what this will do is it will show you how long your actions are taking. So it will show you when it started, when it ended, and how long it's taking. So you can set, so at the bottom you have a console overview. So this console overview shows all the actions that are happening within the application. And you can set the log levels to be different levels. So the most common tools that are helpful for developers is the connection bus retrieve. So the connection bus retrieve shows you all the retrieval actions into the database. And you can set the log level to be info, debug, or trace. So debugging will show you all the XPath queries that you're making and when you're making them. The trace will go one level deeper and show you the OQL queries, the SQL queries, and all the things in between. So it will be very, very detailed. It's always a good idea to start with debug and then go into the trace, because debugging will give you a higher level overview, and then if you find an issue there, go into the trace. Sometimes when you start with trace, you get too confused and don't know where to troubleshoot. The next thing that's really helpful is the Microflow engine. So the Microflow engine will show you what actions. So if you set it to the debug, it will show you the start and end of all your actions. And if you set it, it will show you exactly every single action that the Microflow commits. So it will give you a much more detailed view of the Microflow that you're committing. Another note that I want to make here is that if you need more tools or more log levels, you can use the web services, if you have web services in your application, to troubleshoot them. Or you can also use the connection bus update. So the update is the response from the database to see exactly what is going on with your application. I also want to emphasize that for this particular example, we have the log message on the info level, and if that is the if that is the instance, then you might want to set different kinds of log levels. So right now, because this is set to info, if I were to run this Microflow, it will show up on our console. Usually, it's best practice to do it in debugging, because if you have issues, that's where you want to see that. All right. Now, the next thing that I want to do is go off and explain a little bit more detail on microflows. But before I do that, I want to emphasize that if you have a microflow, and it's taking too long, for example, to run that microflow. So let's say you're generating test data for regions. I want to emphasize that it's really important to make sure that within the Microflow, you can ask, obviously, for confirmation if the user wants to run an application. But you want to make sure that, one, you have a progress bar. So this is what I meant before with progress bar. On every single Microflow that will take longer than, a fraction of a second. Basically, if it takes longer than the speed of light, you want to show progress bar, and it can be non-blocking or blocking, and you might want to add some sort of progress message. So processing data, importing data, please go grab coffee and take a break for the next 5 minutes. So something to keep the users, to help the users understand that the process is going to take a while and it's designed to do that. Then the other thing is you want to make the Microflow call type asynchronous. This way the client doesn't just crash and say, okay, we're not getting any data back. All right, so microflows. Microflows are a sequence of actions, and they use the same core actions as the clients, only through Java action calls. Each microflow is a complete transaction, so either all or none of the actions are executed, and the same principle applies to sub-microflows. So microflows can return instructions to the client, they can open pages, they can refresh objects, they can send messages, and they can also send validation feedback. Some of the really common issues or errors that I see with a lot of users is that they retrieve the same object multiple times within the same microflow. So for example, they retrieve it once on the higher level of the microflow, then they retrieve it again on the sub-microflow. When you're doing retrieves, these are activities that are time intensive, so it can slow down your performance if you're doing retrievals of thousands of objects or hundreds of thousands of objects. So if you don't need to retrieve something, avoid doing that. Commit only if it's necessary. With a lot of new Mendix engineers, they just commit every single action all the time. They don't think about what they're actually doing, but a commit is basically a database action where it persists the object into the database. So if you're doing like 100,000 commits, that could affect performance. The other thing is you want to avoid using commits within a loop. Always use a batch commit. And I'll show you an example briefly after this of what to do and not to do. And again, as I mentioned before, you want to set heavy microflows to asynchronous mode, and you want to add a progress bar on long-running microflows. Batches. So if you're dealing with large data sets, let's say larger than 500, you want to reduce the change on memory heap on the process, and you always want to sort on a batch retrieve. The reason why you're sorting is because you want to know what you're retrieving and at what time. If you don't retrieve, then it could be a very random retrieval. And the other thing is, if you're using any values as a constraint condition on the batch retrieve, you want to make sure that you don't change those batches within the same microflow. Otherwise, it's not going to be clear what you're doing. So here's an example of adding batches and also doing one commit. So this is a simple example where you are retrieving a list of subscriptions. And for each subscription, so for each registration to a course, you're retrieving the person and you are changing the subscription to, let's say the person received the email yes or no. So it's a pretty simple microflow, right? Well, you're going to run into a lot of issues with this microflow when you have a large subscription list. And on top of that, this subscription list also has a fairly complicated XPath constraint. So if you have 500 subscriptions, this might be fine. If you are having like hundreds of thousands of subscriptions or a very large data set, then you're going to run into performance issues. So how do you improve this? Well, the first thing that I want you to do whenever you run into this issue is never, ever, ever commit within a loop. Always commit into the end. So make sure that you reduce the number of commits. So instead of doing 500 persistence into the database, you want to do it just once. So that's the first action that you want to do. The second action that you want to do is to actually create limits, and offsets. And I'm going to briefly explain this, but for more details, I would highly encourage for you to read one of my coworkers' blog posts, Mark Lehane. He goes into great detail on how to use limits and offsets and what kind of issues you'll run into it. So what you're doing is you are breaking down your large data set into smaller batches so that it's easier for the application to process it. So you can create a limit and offset. Within the retrieval, you can specify what the limit and the offset should be. And then you count the list of subscriptions. If the count is the same as the limit, then you reiterate through the whole loop. And notice that there's also log messages that you can add to show you, for example, how many processes you've, how many subscriptions you have processed. So it might look a bit confusing at first, and it might seem a bit tedious, but it's one of the best things that you can do for your application. So for homework after this webinar, I would like for you to go into your microflows and check when you're doing your commits. Are you doing them within a loop? Well, stop doing that once, and two, think of ways to optimize that. Also look at your retrieves. How many times are you retrieving the same entity within your application, or within your microflow? If you're retrieving it 3-4 times, you might want to review that. So again, for homework, make sure that you are, so this is again the bad example. And the wrong thing here is that you are committing the set subscription within the loop. So for homework, please check your loops. Make sure that you do not have, you're not doing commits within a loop, because you want to make as little commits as possible to the database. So that's the first step. So on the best example, again, we have moved the commits of the subscription list outside of the loop. And then the next thing that we're doing is doing batches. So one, move any commit actions outside of the loop. So you're only doing one database persistence or commit. And two, add limits and offsets when you're doing large processing of data. So the domain model. Again, this is an overview of the domain model. You have entities and associations, and each entity is basically a database table with a unique ID, and you have the attributes like name, address, and so on, which are columns within the database. And when you're doing associations, you might want to, the associations are basically the joins between, let's say, the customer and the order. And with Mendix, you don't have to worry if a join is inner, outer, or whatever. The modeler handles all that for you. So what can you do within your domain model to optimize performance? The first thing is you want to avoid large entities. So if you have over 20 attributes, then you might want to think about your domain model, because you could be not normalizing your domain model correctly. If you have unused data from large tables, you might want to archive them, because if you're not using them, then it will slow down queries within the database. Avoid event handlers if possible, because event handlers are always triggered, and they definitely slow down any commits or deletes that you might do. And if you have any unused references or attributes, delete them, find them and delete them. You also want to avoid using any calculated attributes that retrieve data or perform complicated actions. And again, try to avoid the need for unnecessary retrieves. So each association within the XPath constraint will always slow the retrieve down. So sometimes it might be a good idea to denormalize your model. So for example, if you're trying to grab the product name every time that you retrieve the stock and do different things, it might be a good idea to copy and paste it into the stock. Avoid inheritance for over more than 2 levels down. When you're dealing with inheritance, you have more joins on the database. It can be very hard to oversee what the implications are of the changes that you're doing. And also if you're using combination complex logic and also validation rules, it can be very, very complicated, and sometimes, in my experience with Mendix, I have yet to see like 2 levels or deeper of inheritance. So if you find yourself using that, then you might need to rethink of your domain model and your data structure. So this is a simple test case created by my coworkers. If you create 50 batches of 1,000 simple objects, this is the average time of activities that would take to work with those objects. If there is no inheritance, you can see the speed. It pretty much increases at a very fast rate. So you definitely want to avoid having 2 or 4 levels of inheritance. The next thing you want to do is indexes, add indexes. So indexes improve the database read speed. So think of the database read as the retrieval from the database rather than the request or writing of the database. You want to add indexes on larger tables because the effect of it is not useful on smaller tables. And you want to add indexes on attributes that are used in searches or sorts. Examples of these are dates, names, and things like that. And you also want to add indexes on attributes with a lot of unique values. And you want to add, again, indexes when your read actions are greater than your write actions. So only add indexes when you need them. Calculated attributes, minimize the use of calculated attributes because calculated attributes are always executed, and this has a huge overhead cost. And sometimes it could be better to denormalize your domain model. Make sure you don't use retrieve actions on the database in a calculated attributes. Now let's go on into my favorite topic, which is simple XPath constraints. So simple XPath constraints are can be extrapolated to very huge and large SQL queries. And if you remember before, you had an XPath constraint with a schema around it, which converts into an OQL, and then from an OQL it turns into a SQL query. An XPath constraint that might look very simple can be translated into a very, very complex and huge SQL query. So you can view XPath queries and constraints into the connection bus _retrieve log level. And as I mentioned before, there's 2 types of level. There is debugging and tracing. In the debugging, you can see incoming XPath constraints. While in the trace, you can see the parsed OQL, all the added security levels, and what the generated SQL queries are. It's always a good idea to use the advanced search options to identify not association or association. So, or not actions, just by the logic of it, require a lot of time. So it's really important to avoid using those statements or to optimize your XPath queries. The same concept that we do with XPath constraints, it applies to your Microflow and also to the forms. So you want to make sure that whenever you're using XPath constraints, your XPath constraint is understandable and optimizable. So what do I mean by optimizing? This is a simple example. So you're trying to retrieve people who are subscribed which have a grade of less than 5 and greater than 10. So instead of going over the association twice, it's better to restrict it into once. And again, you want to avoid OR statements and not functions because they can generate very difficult queries, and of course performance can be reduced. And you want to, sometimes it's better to actually retrieve multiple objects and do joint list operations rather than do one large, complicated XPath constraint. So here's an example of a very, very large XPath constraint. So you want to retrieve the trainees that are not in the scheduled course or not in the subscription trainee. So this is a very, I mean, just even by an XPath query, it's complicated. And if you translate all this into SQL, it's even more complicated. So sometimes, don't get scared, sometimes it is best to actually do multiple retrieves and limit your list when you're retrieving, and then use list operations such as subtraction or union. For example, the subtraction is the not statement that we had previously, and then union is basically the or statement. So it's better to start off with one retrieval and then limit that retrieval of all the other objects that you're trying to work with. So how important is optimization of XPath queries? Well, very important. Again, there was a study done by my coworkers to look at the test projects with fairly large data sets, and they noticed that when they had when they had OR statements, it took them up to 20 times longer to retrieve information versus if they just used a list and a union of those two objects. So it can be anywhere from, so if you reduce your complicated XPath constraints, your performance can be anywhere from 10 to 20 times better. So security rules also make your process more complicated. If you remember on the overview, the security rules are applied when the Mendix business server interacts with the database. And when this interaction happens, you could have a lot of, especially with a large data set, it could take some time. So rules are checked individually, but if they're equal, obviously they're combined. You can have multiple rules that are caused by having either multiple user roles per user. So let's say Joe from the company has 20 user roles, or you could have multiple module roles per user role, or you could have multiple rules per module role. So this in and of itself can get very, very complicated. So it's a very good idea to try and simplify it as much as possible. Obviously, the more rules you have, the more complicated the queries are, and hence the longer it will take for the response to happen. And if you have like large XPath constraints based on the security rules, that could also affect your response time. So what you should do is you want to avoid combination of rules, and you want to combine user roles when the combination is commonly used. And you also want to avoid large XPath constraints. So going back to the analysis, where could be the problem? So we just covered quite a lot of materials on microflows, on the domain model, and so on. Well, you could also have performance issues. And if you have performance issues, then that's a whole other thing that you could go over. The best thing that you could do, though, is use tools such as Firebug, Chrome developer tools, and identify what the slowest requests are going on the server. So you can easily see like what the HTML is doing and if there is any JavaScript issues. So in conclusion, many factors can contribute to the performance. You could have very complicated XPath constraints. You could have a domain model with multiple levels of inheritance. You could have inappropriate associations. Or you could have, you're not using your batches effectively, for example. So keep in mind the performance when you're creating an app. Do not try to create multiple levels of inheritance. If you're not using an association, delete it. Try to be as lean, as efficient as possible. And always, always, always test your specific situation. Again, I want to say that these are just basically guidelines, hopefully they'll be helpful for you. and the results may vary depending on the circumstances. And again, test performance before going into production. And always make sure that you're testing it with real-life data. So now I just want to open up the forum for any questions and answers. So we have a question by Javen, and the question is it possible to add this time logging to all microflows at once, or do I have to do it manually for each one? So the logs, there is already logs. So let's go back to the modeler. As I said before, there's different log levels on the Microflow engine. So there's the info, and then the debug and the trace. And this applies to all microflows within the application. So what the adding log timing within the activity within the microflow, what it does is it specifies exactly what you're doing. So you're basically adding more to the log information that is already there, and you're trying to make it more understandable for you. So by adding a start and an end time, you are specifying exactly what kind of activity is going on within your microflow. The log levels between the trace and debug will show you more details within the microflow, and it will show you these details regardless if you add a log timing or not. So the log timing activities within the microflow are there to add you more details and to become more readable for the users. The next question, WRT. With regard to the recommendation to commit outside of the loop, is it also true for creation of new objects? In the case of updates, there's a list which you can submit. In the case of new instances, they are not in this list. So if you're creating, so what you need to do is you need to create a list of those objects, and then within the loop, if you're changing them or doing anything like that, then you might want to add within the loop those objects to the list. Is there a way to optimize object creates within a loop? Yes, you can optimize. So the biggest factor in performance problems is the connection with the database. So as I explained earlier, we should try to optimize or retrieve the commits and commits by simplifying the constraints and also retrieving smaller batches. So obviously limiting the amount of commits is one of the most important factors here. However, when you're creating an object, it does not initiate any database connection unless you're committing, but don't do that. All actions take place in memory. So as long as you do not have any after or before create events that access the database, you don't have to worry about optimizing that. The platform already optimizes all this for you. So all you have to do is make sure that you do a single commit for all of the objects you created. And when you're creating objects in an iteration, an option could be creating a list and adding all those objects to the list and committing all of them outside the iteration. So I hope that clarifies the previous question as well. So how about if hidden optimization like retrieve and count combinations? Are there more, and how can we use them? There's definitely more documentation on how to do retrievals and counts. What I covered in here was just a basic combination. Obviously, the more complicated your issue, the more you might want to identify it. So you might want to identify it on a higher level and also go deeper into each retrieve and each count action. I would strongly urge for you to work with the Microflow actions and work to see what kind of things you can do with lists and what kind of operations there are, and so on and so forth. So another question is, hi, are XPath constraints used in the data grid pages and so on? And that is a great question, Sunita. And yes, you use XPath constraints on data grids, pages, and other things like that. And it's really, really important to optimize that as well. And actually, since I have an example for that, let's say we're going into a scheduled course edit and scheduled course edit. One way to improve that is by, we have a subscription new edit. So that example is if we're doing an XPath constraint or retrieving the trainee by an XPath. So in here you're trying to retrieve the trainee based on the user role and also based on the subscription to the current object. So this is an example of using an XPath constraint in a form. Instead of doing an XPath constraint within this form, it's actually much better to use a microflow to retrieve that specific user. So if we go to the microflow, you are using a lot of retrieves and then a union, and that is, again, much better option than using a very complicated retrieve on the page. So yes, the principles that I discussed on XPath constraints and how to optimize them apply when you are doing limitations on pages and things like that. So here's another really important question in regards to the user application. So what do I mean by my statement to combine user roles? Do I mean that it's advisable to have as less module and user roles as possible? That is incorrect. What I'm trying to say is that you want to avoid the combinations of user roles and users. So the more, let's say you have multiple combinations of user roles and module roles, it is much better to actually limit that to as little as possible. Because if you find two user roles that have the exact same combinations on user security, then it makes more sense to actually combine those two user roles into one user role. Oh, can you please show a visual example on indexes so that we can make the best use example? Of course. So indexes are added in the domain model, and you add indexes per entity, as I discussed before. So for example, if I have a lot of scheduled courses, so I've scheduled a lot of courses, you want to add indexes. And you want to, as I said before, add indexes on the attribute that has the most unique value, on the attribute that is going to be searched on, so for example, dates or names and things like that. And indexes, again, it makes it faster for you to read information. So that's the main reason for using indexes. And you might not want to use indexes if your table is small. So in case of that, so here's another good question. In case of batches, is it possible to split up a microflow into multiple flows, running asynchronous, having multiple workers together? Yeah, you can have pretty complicated batches. You can have like batches within batches and microflows within sub-microflows. If let's say you're doing a data import, for example, I would say and recommend to split up your logic into the import part and then the transformation or the commit part. So you want to make sure that your microflows make as much sense as possible, and you can use, again, batches within all microflows. So it can get pretty complicated. Another question, avoid more than 20 attributes. What if, one second, so what if you have all kinds of attributes that are computed to save to avoid computing them at retrieval? So again, these are just guidelines. 20 attributes is just a guideline. In some case scenarios, you will need more attributes, and that you cannot avoid it. But you want to make sure that you do your data normalization as best as possible. So one-to-one references and one-to-many references, which one performs better? So those two references are very different. So one-to-one reference is one customer, one order, or one customer, one billing address. And then one-to-many, so it's not really about performance in this instance. It's more about what makes sense to use within your domain model. If you have to use one-to-many, which is the most common reference or association in Mendix, then you have to use one-to-many. I would recommend, though, if you're using many-to-many associations, those are rarely used, and what that means is that you're missing some sort of transactional entity between those two entities. So you should be more careful when you have many-to-many associations, because usually that implies that you're not denormalizing or identifying your entities correctly. Let's see, there's a lot of good questions, so I'm just reading them. Will the warning window list us the unused associations also? The best way that you can find unused associations is by going to Edit, Find Advanced, and in here you can search for documents, event handlers, pretty much unused items. And if you search for unused items, you will see a list of all the items that you're not using in your application. I would strongly recommend for you to delete those unused objects. They're taking space and not being used. So, and you can do more advanced searches to find more information and more documents. And it's very helpful for when you're developing. So here's another example from Echo. We have a mobile application. To avoid data loss in the event of a bad network coverage, we currently commit on every field change. Well, what do you suggest for this situation as an alternative? So in this instance, you still want to optimize, and you want to also, I'm sure some of you might have attended the error handling workshop. But that would be something that you might need to use in here. Find a way to handle any errors that happen within your application. When I mentioned batch, did I mean the limits and offsets, retrieve, and commits that I've shown? So yes, that is correct. So batches, what that means is that instead of taking care of all your data, like let's say 100,000 fields all at once, you're breaking it down into smaller components and using limits and offsets to break it down. And in the limits and offsets, you can determine how much you are limiting your application. So there's quite a lot of other questions. So there is a question from Richard. I have a question about the following XPath converted to OQL and that is converted to the SQL. Are SQL statements saved inside the runtime when the runtime is executing the microflow? There is no saving of the microflows inside the runtime. It's just showed and into the console live when you're running the application.
Okay, thank you, Daniela. We have a few more questions, but we'll make sure to follow up with them. We're coming up on the top of the hour now. And thank you, everyone. Those were great questions, and thanks, Daniela, for taking us through them. Before we conclude the webinar, I'd like to invite you all to our next Expert Services webinar on January 30th. We have a great topic planned. Solutions engineer Bailey Everett will go over mobile application development best practices, which I know is on the top of mind for a lot of companies. So you can visit mendix.com/expert, E-X-P-E-R-T, right now to sign up for that webinar on January 30th. And again, we'll answer these final questions as soon as we can. And thanks, everyone, and enjoy the rest of your day. And please take a moment to fill out that survey.
Thank you, everyone. It's been a pleasure.